Looking here at how to use probability trees, we're starting with independent data. This is where the first lot of probabilities won't affect the second lot. Here's an example of that type of question. Abby rolls a fair six-sided die twice. She wants to know the probability of getting a 6 both times. First, complete the probability tree for this data. So if you have a look, you'll see that you've got the first roll, and you've got a branch to say that she gets a 6, and another branch to say that she doesn't get a 6. What you have to think about here is that there are 6 sides on that die, so both of those probabilities will be out of 6. Only one of those sides is a 6, so the probability of throwing a 6 is 1 out of 6. The other 5 are not 6s, so the probability of throwing a number that isn't a 6 is 5 out of 6. If, having thrown a 6 the first time, Abby throws another 6, we know that's still going to be out of 6, so we can put those for all the options below for her second roll. To get a 6, the probability is 1 out of 6. Those two options there, where she's thrown 2 6s, we're going to call that 6, 6. And you'll see why that's useful when we go to answer some other questions later. If, having thrown a 6 the first time, Abby then throws the second time but doesn't get a 6, the probability here of not getting a 6 is again 5 out of 6, and we call that one 6, not 6. If on the first roll of the die, Abby doesn't get a 6, that's 5 out of 6. But then on the second she does get a 6, that's 1 out of 6. And we're going to call that one not 6, 6. And the final option, both times she throws a number that isn't a 6. First roll she doesn't get a 6, and the second roll she doesn't get a 6. So that's another 5 out of 6, and we call that not 6, not 6. There's the completed probability tree. Now we're going to answer some questions. What's the probability that Abby will throw a 6 both times? So we put that tree back. We're looking at 6, 6. She throws a 6 both times. So that's that line there. The first probability, 1 out of 6, and then we multiply that by the second probability, which is 1 out of 6. And if you remember how to multiply fractions, you'll have your answer, 1 out of 36. When you do these, just check whether you can simplify the fraction at the end, but in this case you don't need to. A different kind of question here, and there's a bit more to this one. What's the probability that Abby won't throw 2 6s? Now we need to be careful with the wording with these kind of questions, because the question could have been, what's the probability that both times she doesn't roll a 6? And that would just be not 6, not 6. But the question says she won't throw 2 6s. That could mean she throws 1 6 on one of her rolls, but not on the other. So we need to include not 6, 6 and 6, not 6. Looking at the first one, 6, not 6. That's 1 6 multiplied by 5 sixths, which gives you 5 over 36. A word of warning with these ones, don't simplify them if they can be simplified at this stage, because you need to add them together at the end, so the denominators need to stay the same. The second option, not 6, followed by a 6. So that's 5 sixths, followed by 1 sixth. Multiply those together and that's the same, 5 over 36. And then the last option, not a 6, followed by not a 6. So that's 5 sixths multiplied by 5 sixths, which is 25 over 36. To get the probability of all those combinations, we need to add those results together. 5 36ths, add 5 36ths, add 25 36ths, which is 35 over 36. And that's the probability that Abby won't throw 2 6s.